Hello everyone, I am Mrs.T.ARUNDHATHIE, Assistant Professor of Geology, Department of Geology from A.D.M. College for Women, Nagapattinam. In this video, we are going to see about paleontology, especially the class Cephalopoda, which comes under the phylum Mollusca. What are all the content we are going to see? Introduction, then morphology of Cephalopoda, and the three classifications of Cephalopoda, and at last geological distribution. First, what is cephalopoda? Cephalopods, it means cephalon means head and poda means food. So, cephalopod, this is the meaning which comes under the Greek word. It refers to a group of soft-bodied bilaterally symmetrical animals with well-developed head and body, which include present-day forms octopus, squid, cuttlefish and nautilus, while the extinct types are belemnites, ammonites and goniatites. These are all the things comes under cephalopods. This taxon is the third largest molluscan class, which comprises more than 800 described species in the world, which is said in the Lindgren et al. Classification. They are exclusively marine animals which started their life in Cambrian. Cambrian comes under geological time scale. It is one of the age of geological time. They are more active and quick movers and intelligent carnivorous predators with varied shell morphology and highly developed nervous and visual systems. They are most active and quick movers, intelligent carnivores. Then its visual systems are very clear. Then morphology of cephalopods. Cephalopods are a diverse and highly evolved and morphologically complex class of mollusca. The coiled calcareous, it means the shell is composed of CaCO3. It is calcareous shell, which provides an excellent opportunity to the paleontologist to understand the soft anatomy of the shelled cephalopods. The visceral mass is located in the rear body chamber. The head and foot are fused closely together. The head bears the mouth and a pair of eyes. The foot is modified into many tentacles, which are used mainly for locomotion and catching the prey. Above the head, there is a tough fleshy fold termed as hood. This is the morphology of cephalopod. See, in this picture, you can see the cross section of cephalopod, which is coiled in formation. In this coiled formation, you can see center a tube-like formation is present from the inner to outer, that is known as the siphuncle, and the septa which connecting the two chambers is known as the septa, and the outer layer is known as the shell, and at last the opening side you can see the tentacles, and the opening side is known as the mouth, and the inner side which is coiled is known as the hood, which is present in the center. In this you can see the gastrointestinal ligament, stomach, intestine, ovary, heart, kidney, gills in the opening side you can see, and etc. This is the lower jaw and upper jaw are also present. A hood, shell and the siphuncle, that tube-like formation are all present. This is the cross section of cephalopod. In this we can see the morphology. Then classification of cephalopods. Paleontologists classify the cephalopods into three subclasses on the basis of their shell morphology. Cephalopods are divided into three subclasses, or we can say it is orders. Order Nautiloidea, order Ammonoidea and order Coeloidea dibranchia. First we can see the order Nautiloidea. Nautiloids are the oldest form of cephalopods and may have provided the ancestral stock from which the Ammonoidea and the dibranchia were derived. Most of them are extinct. The several of the nautiloids in the tropical region of Asia gives us an opportunity to examine the anatomy of the primitive cephalopods. The shell is always external and consists of a tube which tapers to a point at the end and may be straight, arched or spiral. It may be straight, arched or spiral. It is based on its formation. In the spiral form, the holes may be separated or in contact throughout. Commonly, the shell is helicoid spiral. In the previous picture we saw it is a spiral in shape. In planispiral coiling, the holes are in one plane. Then morphology of Nautiloidea. The anterior shell is divided into many number of chambers by means of transverse partitions called septa. In the picture we saw septa. They are connecting the chamber. So number of septa, many septas are present in the chambers, between the chambers. The chambers usually increase in size towards the aperture of the shell. The body of the animal occupies the last chamber and called as body chamber. In the opening you can see the body chamber. All the chambers except the last chamber or body chamber are gas filled. The shell grows by addition of materials at the margin of the aperture. After certain period, the body of the animal moves forward and a new septum is secreted behind it. All the chambers are transversed by a small cord-like prolongations, which is a very small cord named prolongations of the posterior end of the body. It containing the arteries and known as the siphuncle. See this picture. In this picture, you can see the order Nautiloidea, which is helical planispiral in shape, and the opening is very large. And see, you can see septa that septa impressions are showing as curved. This is the order Nautiloidea this picture shows. Then, in many fossils, nautiloids, the siphuncle is completely replaced by a calcareous tube. The septa are often prolonged in the form of funnel around the siphuncle. These funnels are termed as septal neck. In all nautiloids, the septal necks are directed backwards only. The aperture of the shell has, in some cases, a simple margin, straight or slightly curved. In nautilus, there is a sinus at the extreme margin, and the lines of the growth on the shell and are correspondingly curved. The shell is fully of curved only. The lines where the edges of septum touches the wall is known as the suture line. The shell which covers the embryo in the cephalopod is known as the protoconch. In the previous picture, we can see the shell. It is the fossil form of Nautiloidea, and it is not the living form. Okay? So in the fossil, you cannot see the shell. You can see only the cast which present inside the mold. We cannot see the shell. And the suture lines are also clearly present in this fossil. Then distribution of nautiloids. At present, nautiloids are represented only by few species like nautiloids found in the Indian Ocean and East Indian Archipelago. They lived in benthonic shallow water conditions. They first appeared in Upper Cambrian period and their number increased during the Ordovician and the Silurian periods. Earliest forms were having the highly curved shells, but later the shell become straight or slightly curved. Between the Devonian and the Carboniferous period of geological timescale, the decline of nautiloids were started. During the Permian period only, Orthoceras and the Nautilus continue to present day. Orthoceras is also a fossil form of nautiloids. Then second order Ammonoidea. Ammonoids are the most important member of stratigraphically among the cephalopods. They become extinct completely after the Mesozoic period. The structure of ammonoid shell is very similar to that of Nautiloidea. Nautiloidea and Ammonoidea are almost equal in shape. The size is usually coiled in planispiral, but in some forms the shell is partially uncoiled or wounded into helicoid spiral. In ammonites, the suture line shows complicated pattern. The siphuncle is at the margin of the shell, generally near to the outer margin. In order Ammonoidea, we can see some suture types. The suture lines in Ammonoidea. Suture line become more complicated during the evolution of ammonoids. The suture line ammonoids are primarily grouped into three basic types. In this, the first one is known as goniatide suture. It consists of simple lobes and saddles. The individual lobes and saddles are not further divided. This type of suture is mostly characters the Paleozoic ammonites, in which the ammonites are formed during the Paleozoic period. For example of goniatite suture, we can say Middle Carboniferous. During the Middle Carboniferous age, there are more ammonites showing the goniatite type of suture. Then second type is ceratite suture. This is characterized by very smooth rounded saddle and much divided lobes. It has many lobes. Ammonites with ceratite type suture lines are known to have appeared first in the Carboniferous and persisted until the Triassic. It has lived from the Carboniferous period to the up to the Triassic period. Then third type is ammonite type of suture. In this suture, the suture have both the saddle and lobe, which were mostly divided into some varieties. The shell with ammonite type of suture appeared first in the Permian period and disappeared in with the extinction of ammonite in general at the close of the Cretaceous period. In some ammonites, the external margin of the shell is provided with a ridge or keel, in which form the ribs of the two sides are not continuous. So these are the future lines of ammonite, which is divided into three types. Then third order is known as the dibranchia. We can say it is dibranchia or belemnite order. This is the living form of dibranchia, and for example, we can say cuttlefish. They are much less important geologically than ammonites and nautiloids, because ammonites are very extinct type. The only common fossil form in dibranchia is belemnites. Belemnites are found everywhere throughout the region of Ariyalur and Tiruchirappalli. It comes under the suborder Decapoda. Belemnites consist of the shell of three parts. First, the god or rostrum, which is the head part, and the middle one is phragmocone, and the last one is proostracum. The god is small solid and is much more commonly preserved than the other parts. It varies considerably in size and shape, being cylindrical, conical, or fusiform. The end, which was directed away from the mouth, is always pointed, and at the other end there is a conical cavity called alveolus. And the phragmocone is a hollow cone part which fit into the alveolus at the broad end of the god. It is divided into a number of chambers by transverse septa, which are concave in front. At the pointed end, the phragmocone, there is a globular or ovoid protoconch formed of calcareous materials. The head of the belemnite is in front of the proostracum. The stratigraphic range of belemnites is from Jurassic to Cretaceous and are especially abundant in argillaceous beds. In this, you can see the Cretaceous. Cretaceous period comes under the geological time scale, and previously I said around the surrounding of Ariyalur and Tiruchirappalli, there are more belemnites we can see, and the area we can say commonly as the Cretaceous of Tiruchirappalli. It is very famous for the marine sediments and also for belemnites. Belemnites comes under the third order dibranchia of cephalopods. See, in this picture you can see belemnites. The second picture, it is the fossil, belemnite fossil. You can see everywhere around the Ariyalur and Tiruchirappalli region. And the first picture you can see the parts of belemnite. In first, see tentacles, like it is the head or arms, and then protoconch, siphuncle, then cone-like structure in the middle, that is known as the phragmocone, and at the end of the phragmocone you can see protoconch and last rostrum. See, geological distribution of cephalopods. The earliest representatives of ammonites are found in the lower Devonian period and later Cretaceous. The ammonites constitute valuable index fossil for the stratigraphic studies due to various reasons. They evolved quickly and split into a large number of genera, each having limited stratigraphic range. Most of them are free swimmers and had wide ecological tolerance, and hence they were quickly and widely distributed geographically. They are relatively more commonly fossilized and easily identified because of their distinct characters. Because of all these factors, ammonoids are used as the dependable index fossils. You can see ammonoids are used as the dependable index fossils. Index fossil means that we can see the that fossil that individual fossil in the wide distribution and short period. In geological time period, you can see it is very short period, and the distribution of the fossil is wide, geologically distributed. That is the index fossil, which is especially for marine Mesozoic strata. Another important ammonoid is that some of the specific genera among them are known to provide illustrative examples of the biogenetic law. Ontogeny recapitulates phylogeny. This is the biogenetic law when the shell of particular individual of ammonoid is studied. The earliest sutures are relatively simple ones, but as successively the later sutures studied, they are found to be advanced in complexity. In many specific genera, this change towards the complexity is due to the evolutionary development. Thank you.